Next, we have a talk on overcoming LLM's limitations with agentic workflow by Mr. Harshit Surana, and I kindly request Professor Chiranjeevi to introduce our speaker.
Hello everyone, good morning. So today we have many pre-trained models in speech, text, and vision, right? So can these models directly deployable? Are any practical aspects do you consider? So the coming two talks is about the dealing the practical aspects in industry scenario. The first talk is from Harshit Surana. He is a research scientist at Alien AI, and he is a co-founder of few companies like Deepflex and Kavos Genius. And he did his graduation studies from CMU in NLP area. And before that, he has a small connection with the LTRC. He did his undergraduate thesis here. So I'm requesting Hashit to give a talk. Thank you.
Does the clicker work? Can you guys hear me fine? Okay. So hi, I'm Harshit. I'll be talking about overcoming LLM limitations with the agentic workflow. And yeah. Yeah, so I just first wanted to thank some of my colleagues who have been part of this research. So Bodhi, who's also the co-author of the book, and Peter, we are sort of co-leading the project. And then Chris and Grace, who are at the right side, they are helping us with the biology. So all the biological labs in Seattle Hub for Synthetic Biology, and Allen Institute for Neuroscience. Also from CMU, Graham Newbeck, who we are collaborating on with code generation. So we'll talk about code generation, the use of agents in code generation and software engineering a little later. But before I do that, this is something I couldn't say yesterday was I started my NLP and I learned about NLP and research at IIIT. I learned about combining rule-based systems and statistical systems. Here, I learned it from Deepti ma'am, I learned it from Sangal sir, I learned it from Anil sir. So yeah, thanks a lot. So yeah. Yeah, so we all agree that LLMs have revolutionized NLP, but they often fall short in key areas. And I think all of us would agree with that. Where do you guys feel that, what are the areas where you feel that NLP has, or the LLMs have failed, right? Well, we discussed about hallucinations earlier, but what are the key areas would you feel when you use ChatGPT or use Gemini or Claude that they can't do what something that you want them to do? So I'll just wait for a minute and if there are any answers from the audience. Hallucination is one. Is there anything else? Okay. Sorry, yes. Hmm. Yes, exactly. Right. Right. Yes. And so essentially it cannot follow a complex task because, yeah. So yeah, so what he was mentioning is that a lot of code or a lot of text is generated, and you want to change a small part of it, and that cannot be easily changed, right? Because it changes everything, and it doesn't change what you asked it to do, right? And that is essentially an example of a complex task. So we cover a bunch of these problems that LLM limitations have for advanced task. Hallucination is one, but we also have LLMs are opaque. You don't really know what's happening inside. They often have limited context. Even the larger models, which have 2 million window, they also have pretty limited context. If you look at mono repos, which have tens or 20 million lines of code, which is quite common in a large industrial setting, they often also have poor adaptability of out of distribution domain and tasks. They work well, when something is part of their pre-training. They don't work otherwise. And obviously, they lose memory over longer context, non-trivial to verify, and cannot integrate into specific user workflows. Anything else that you guys want to talk about that this list doesn't cover? Okay. Yes, reasoning, and I bring that up. Yes, that's a very important point. The one key thing whenever you talk to anyone in industry or anyone in academia and they want to use it is, hey, this is a cool demo. How do I use it? Right? This is a very common pattern that we see whenever companies are adopting LLMs, and at times research groups are adopting LLMs, right? So how can we tackle this, right? So I'll talk of a simple example. This is an example which is sort of inspired from one of Andrew Ng's slide. And this is the example where you either look at non-agentic workflow. Imagine you're generating NLP code, and there are two ways to generate that code. You generate this code by saying something like, write a Python script that uses the Hugging Face model for sentiment analysis given a bio dataset. Please type out the code in one go without waiting or even using a backspace, right? So this is how a default ChatGPT works. But this is not how we as human beings program, right? But by default, whenever you're using ChatGPT, and I think the person who asked the question, this is, we are giving, when we give a prompt, we are essentially asking the model to behave in this manner. What really works is agentic workflow is what really works is how you would solve that problem, which as an example is you will, in this NLP code problem, you will first define the problem in a certain manner. You will talk to domain experts, like this is the bio domain, so you'll talk to doctors or clinical data scientists, and then you will start with a baseline. You'll start with a baseline model, and then you'll iterate. You'll have bugs, and you will fix, and so on and so forth, right? So you revise your code. You research, go outside in the world, talk to people, or search on the browser, and you debug your code, right? So that's something that is just missing in the single shot example that I gave earlier of of NLP code in bio domain. And how can we solve that? What are the solutions, right? And these are these agentic design patterns. We'll briefly talk about these agentic design patterns, and then talk and give two concrete examples from our work on how they helped in different use cases, right? So one of the design patterns is reflection. We want to reflect, just like we reflect as human beings, we want agents to reflect. The other design pattern is tool use. It's important to use tools. Agents by default don't have access to tools. Planning is something that PJ and sir, you mentioned. So planning and reasoning are linked. And also multi-agent collaborate. We work better when we work together. So the first one is reflection. I cannot read this very well. Maybe I'll have to turn back. No, I cannot. Maybe I haven't updated my eyesight, but yes. So reflection is the first one. So what we essentially want is you verify and reflect the LLM outputs either by some external feedback, or external feedback could be something like a unit test, or by some other LLMs or those LLMs itself, right? So use the reflection to iterate the results, right? So given even the example that the person asked that, hey, I have a lot of code, I asked it to change, and I don't know if it worked or not, right? LLM also doesn't know whether that specific change worked or not unless it passes through a unit test, and the unit test tells that it failed. Now, once you have that information and you convey that information back to the LLM, and you have a loop, then LLM will often generate a much better answer. So there are different models for that. One is self-refine, which came out of our group and a bunch of collaborations with CMU, Google, NVIDIA. And then reflection is an even more popular one, which uses the structure of structured unit tests to iterate all kinds of code generation. Tool uses another LLMs by default. They don't have access to tools. It becomes much better when you give tool usage to LLMs. Even when you're asking ChatGPT to generate a particular code, or if you're writing a paper, you're asking ChatGPT to write a certain parts, it's not aware of the literature, or it's not aware of the coding environment, as an example, right? So it's important for these models to be aware, to be connected to browsers, APIs, code execution. Custom code is something that we have seen it being important, because often LLMs are also not very good at generating very domain-specific code in a very narrow domain of science, or a very specific, or a narrow domain of systems engineering, right? And search engine and so on, right? So AppWorld is one example where we're building this benchmark. And this is how this general function calling happens. So now a good proportion of LLMs do support function calling. Not everyone does, but even for the LLMs that don't support function calling, there are ways to sort of have them emulate function calling without proper function calling. Right, so this is the tool use. Planning and reasoning is what was also mentioned. So planning, right now, when you ask an agent to do something, ask LLMs to do something, they don't have a plan of what they want to do, and they do things from start to finish. But the results get much better when there's like a task ledger. It has a list of things it wants to do, and it's keeping a track of them, and based on that information and more user prompt, it's able to reason over them and change their plan. So AutoGen is like a popular framework from Microsoft that is used for multi-agent collaboration, and AutoGen recently released Magento, in which they were having a lot more planning and having task ledgers and process ledgers and so on. Right. And then the best part is things work generally well when a lot of people work together and they collaborate. That's the point of research. That is what we discussed in this talk as well. And this is multi-agent collaboration, right? So here you have the example of ChatDev, which was by Tsinghua University. It was, I think, in ACL 2024. And the colors don't render well, but essentially in this example, imagine you are like running a software company and you give a high-level task, but you have different departments like designing, coding, testing, documenting, and these different agents all work together. And in ChatDev, it's also somewhat visual, and they help you get an answer to a particular problem, right? So these multi-agent collab by itself doesn't work perfectly, but these are these broad design patterns. And when you apply these design patterns for a particular problem, well, then you start getting much more better results. Right? This is another example from our group, and this was in ICML 2024, and this is around data-driven discovery. So we have these 4 different agents, which is like a planner, a data expert, a programmer, and a critic. When they all work together along with some agents, memory, and access to literature, external literature, then they're able to do much better with scientific discovery, both for NLP as well as biology. And so I'll probably pause there. I've covered these 4 design patterns, and if there are any questions that you have around these design patterns before we go to 2 concrete examples. Cool. So let's deep dive. Sorry.
I have a question.
Yeah.
So let's say that in a dialogue, let's say that this is a customer support dialogue chatbot. User has 2 goals to get the answer from the customer support, and
user has 2 goals.
Let's say that he has 2 questions. For example, insurance chatbot. Okay. And first question is like, you want to know the status of the amount of the premium. And second thing is like, how many days, how many more years he wants to pay.
Right.
Okay. This happens in the series of dialogue turns.
Sure.
Okay. When the dialogue switch happens, I mean like from the first question to the second question, if the goal has changed, user goal has changed, the identification of the goal switch is a major challenge.
Yes, it is.
Yeah,
and that's why keeping a track of goals can be super helpful, right? Keeping a track and also updating them.
Okay.
Right.
Yeah. That's what I mean. How I'm wondering how this can be solved.
So you sort of have a task. You sort of have a task ledger. In your case, it will be like a goal ledger. And you every time a user asks a query, you'll figure out whether that's a concrete goal in the list of your defined goals or not. And if it is, you'll keep adding more to this goal ledger. This goal ledger will go along with the other things as a context to your LLM call, right? So the goal ledger always is there because LLM needs to know what has happened and what has not happened. And then you have another call where you identify what all goals have been met and if any new goals have been added. New goals could be added either by LLM output, because LLM may figure out, hey, your policy has these issues that may lead to some other new goals, right? Our LLM goals can happen by the user query as well.
Okay, but we are adding.
Sorry. Sure. Okay. Yeah. Okay. So I'll just pause, and I have anyhow kept a lot of slides which are deep dive, which I don't know if we'll have time to go into. So, but yeah, I'll probably complete these two concrete examples, right? So the first one is software engineering with LLMs, and software engineering is not just code generation, is not just coding, as we all know. So there's this work by OpenHands, like it's like now one of the most popular LLM repos. It was by CMU, UIUC, and now there's a research. There's a startup as part of it. And what they do is, I don't think we can read their overall structure very well, but essentially, unlike coding on ChatGPT, where you don't have the environment, here you have the full coding environment. You also have access to different agents like browsers, but also agents which would work well on a particular part of, say, code editing or data science. They also have access to runtime and various tools, and you can plug different LLMs. As you may have seen, certain LLMs work better for certain use cases. So optimize for both performance and cost is something that could be done if you have pluggable LLMs. And generally, it's like a top repo, 37,000 stars on GitHub, right? But how do we know it works well? We need a benchmark. Without benchmark, we can't really qualify if these things work well. So there's a benchmark by Princeton called SweBench, and it has become like super popular. What they essentially did is scraped a lot of PRs from out on GitHub. They added some filters to it, make sure that there is a test, because otherwise, how would you verify that that a particular code generated works, right? So they made sure that there's some test, and those tests contribute to a code resolution. And this laid a foundation for a lot of software engineering related both agents as well as startups. But there's an issue with SweBench, and what the issue with SweBench is, not everything is verified. So all the information that is provided in a GitHub ticket, that's not enough. That's not enough to solve. And I think it's showing different distributions. I'm not sure if we can see the colors, but essentially, what I would say is that because SweBench had a bunch of issues, OpenAI took SweBench and they made SweBench verified, which is that they had like 90 plus software engineers, and they looked over like some 1,500 samples and figured out the samples in SweBench that really work and that are completely constrained, right? So they can solve a particular task just with that information, and we have a fully verifiable way to know that the problem is not underspecified, or all the information is there to make sure that it will be passed, right? So this is called SweBench verified. Now this is the most popular benchmark for coding in real-world software engineering challenges, and people run it on OpenHands with their Code Act agent. And as you can see, these are slightly different models, but broadly from a score of 7. The latest OpenHands agent with a slightly better Claude model had a performance of 53. So OpenHands is the first agent to cross 50 in SweBench verified. And what did they do for that, right? So first of all, one thing they included is task planning. As a software engineer, you do a lot of task planning, and they're telling me I have a minute. I'll probably take 2. But you need a lot of task planning. You need ability to traverse directories, and they also added function calling. So very quickly, we also are contributing to OpenHands. It's a great contribution. It's a great place to contribute to. We are contributing on the evals side and the data science agent side, and it's just a very heavily growing repo. I'll take a quick detour on say scientific discovery. It will take just a minute, and there are 3 broad methods of scientific inquiry. One is theoretical science, where you develop theories. There's experimental science, or there's observational science, right? And what we are focusing for the second concrete example is observational science, which is the data is already there. You don't need to develop new theorems or you don't need to run more experiments, but there are data sets like the US Bureau's National Longitudinal Study or Nurses Health Study, which has led to like tremendous science. A lot of medical innovations we use every day came out of these large longitudinal studies. And essentially we use that for data-driven discovery. I will have to rush through data-driven discovery, but essentially we use the agentic system along with a bunch of other bunch of other things like memory and planning over it. And it ended up having pretty good results. And in fact, this was a position paper. It sort of started with a renaissance on scientific discovery with a focus on data. Now, I think there are half a dozen benchmarks related to data-driven discovery. I'll skip through all of this for now. Just the last thing is that all of the stuff that I showed around data-driven discovery is part of the broader vision that we have is like a research agent that can do data analysis, but can also do search, can synthesize literature, can find hypothesis or generate hypothesis, and then can plan an experiment and execute it, right? So this is called NORA. And all the agentic workflow, agentic patterns that you saw in the earlier presentation, they are all applied there. And I'll end with one leading question. All these patterns that you saw here work well if you have limited data, but on an industry scale, when you have petabytes of data, or you have millions of lines of code, then a lot of these patterns may not also directly translate, but they still somewhat hold. And we can probably discuss offline on how to make sure that work well at that scale. So that is pretty much it. So yeah, thank you.
Yeah, thank you, Harshit.